I just want to briefly review the idea of the fundamental theorem of algebra. And that is, if I had something to the fifth power, if that was my degree, fifth degree, then I'd say there's 5 solutions. And they might be real, they might be imaginary, but there's 5 because of that exponent, the biggest exponent I can find. So if I look up here and I see x to the third, I know there's going to be 3. There's 2 distinct solutions, negative 3 and 4, but 4 happens twice because x minus 4 is squared. And just as a recall, it's just going to touch the graph there. It's not going to go through if it's to the second power. But I do have 3 roots. I have negative 3, I have 4, and I have 4 again. If it happens twice, I count it twice. Okay, so let's find all the real zeros of the function. And we can take a look at this graph the best we can here. And it kind of looks like, if this is 1, it looks like I'm going to have something like, that might be 2/3, maybe. I don't know. And this kind of looks like negative 1 to me. And that kind of looks like negative 6 to me. So I'll keep those numbers in mind as I go ahead and have to guess a little bit. My possibilities are the factors of 12 over the factors of 3. Okay, so the factors of 12 are 1, 2, 3, I should say plus or minus. 4, 3 and 4 make 12, 2 and 6 make 12, and 1 and 12. Once I get to the middle, the 3 and the 4, I can start branching out, what goes with what, that kind of thing. Oops. Alright, and on the bottom, I have factors of 3, or 1 and 3. So my total possibilities are 1, plus or minus. I'm just going to write it one time, but I mean it for everybody. 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5, oops, not 5, 6 over 1, 12 over 1, and then over 3. So I have 1/3, and 2 over 3. And 3 over 3, but I already have 1, so 4 over 3, 6 over 3, but I already have 2, and 12 over 3, I don't need that. Okay, so those are my possibilities right there. And I was talking over here about maybe having 2/3 as a possibility, and 1 as a possibility, and 6 as a possibility. More specifically, a negative 6, and a negative 1. Okay, they're all plus or minus. But okay, so I only need to find 1. As you see, I have x to the third. I only need to break it down one time. So let's see. I might as well just try negative 1, huh? So negative 1, and I'm taking my coefficients 3 and 19 and 4 and negative 12. And I'm going to synthetically divide here. 3 comes down times negative 1 is negative 3. Plus 19 is 16. Times negative 1 is negative 16. Plus 4 is negative 12. Times negative 1 is positive 12. And I do get 0. So that means that negative 1 worked. Yay. Okay. Now, what does that mean? I have x. What goes with negative 1? Well, plus 1. So x plus 1, the root of that is negative 1. And then I also have this 3 right here. 3x squared plus 16x minus 12. And I've got to try to factor that other piece. So let's see. Maybe it's not worth stopping. Maybe I should keep going. But let's just do it. We'll say 3 times 12, negative 36. Factors of negative 36 that add up to positive 16. So I'm going to have my big number be positive. So factors of 36, let's see, that add up to 16. Well, I know it's not 6 and 6, like a positive 6 and a negative 6. That's not going to get it done. What else could we say? We could say 9 and 4, negative 4. That's going to be 5. That makes it worse. How about 12 and negative 3? Well, no, that's no good either. And what am I missing? I need 16. Oh, how about 18 and negative 2? Okay, that'll work. So we'll say 3x squared plus 18x minus 2x minus 12. So just to remind you, I took this middle term and I wrote it with two different numbers, but it still adds up to 16, so it's still the same. And I'm going to factor something out of these two. I'm going to factor 3x out. X plus 6. I'm going to take out a negative 2 out of the next one. X plus 6 happens again. So now let me write it all together. X plus 1. That came down from up there. And then I have x plus 6 because it happened. And by the way, that shows my negative 6 was true. X plus 6. And I have 3x minus 2, which kind of testifies to the 2 over 3 up there. So that works as well. If I put in a 2 over 3 right here, I'm going to get 2. And then I subtract 2, I get 0. Okay, so my values are negative 1 for this first one, and then negative 6 for the second one, and positive 2/3 for the third one. Those are all my real zeros, or all my real roots right there.